Hello friends, welcome to part 3 of Mathematical Physics Question Paper Solved 2019 set by Dibrugarh University, first semester, BSc first semester. So in the first part and second part, we have solved from question number 1 to question number 6a. So now in this video, we are going to start from 6b, question number 6b. So let's start, and before we start, please subscribe the channel if you are new to my channel and hit that thumbs up button if you like my videos and share with your friends and help me to grow the channel and inspire me to create new contents for you. So now let's start. Now let us solve question number 6b. Right, this is 6b, question number 6b. So here you see we need to find grade phi at this point. So here phi is given, this is the phi. So let me write the given things here. Phi is equal to this one, and let's find grade phi. So that is del phi by del x I cap, and del phi by del y j cap, and del phi by del z k cap, right? So now you see del phi by del x will be here we are going to take y as constant and z as constant. If you differentiate partially, then what you will get, derivative of x square with respect to x, that's gonna be twice x, and y is taken as constant, so next part is z, right? Then if you find the derivative of phi with respect to y, then you have to take x and z as constant. Then doing so you will get, so here it is I cap, and here you see x square j cap. If you differentiate this phi with respect to y, then you will get x square j cap, right? And if you differentiate this with respect to z, when you differentiate it partially with respect to z, then you have to keep x and y as constant, right? So you know those I hope you know those things, right? So that's what we have got. Now at the point -1, -2, +1, right? At this point, let us put the values of x, y, and z here. We're gonna get grade phi at this point will be equal to this. So here we have put x, y, z respectively equal to -1, -2, and +1. So that's gonna be our result. Here you can see. So this is the result we're gonna have, right? So this is our answer. That's how we can solve this. Okay, so now let's move on to next question. Now question number 6b, this is 6c. So here find the unit normal vector to the surface of this at this point. So first let us find the normal vector here. So z is equal to this one, x square plus y square. So how to find a normal vector? So normal vector is equal to grade z. So let's find a gradient here, then you're gonna get this, right? J cap. So here z by del z k cap. So if you differentiate this z with respect to x, then what you will get? So take y as a constant, then you will get only twice x here I cap. Then if you differentiate this z with respect to y, then you will consider x as constant, then you will get twice y. So and there is no z, that's why last component will be 0, and at this point this vector becomes equal to twice I cap, putting x is equal to 1, then 4 j cap, putting y is equal to 2. We have got this. So this is the normal vector at this point. Normal vector at this point, we have got this. Now unit normal vector. So how to find unit normal vector? So this is the let's find the magnitude of this vector. Then you will get 2 square plus 4 square root over 2 square plus 4 square, and it's going to be 4 plus 16, that's going to be 20, which is equal to nothing but 2 root 5, right? Because 4 5s are 20 and square root of 4 is 2, right? This is 4 5s are 20 and square root of 4 is 2. So unit normal vector, okay, normal to z, unit vector normal to z is nothing but grade z by magnitude of grade z, right? So that's going to be equal to, we know that del z we have got 2 I cap plus 4 j cap divided by its magnitude is 2 root 5, and if you evaluate this then you will get this. So this is our results, right? So hope you have understood this. So this is your answer. Now let's move on to next question. Now let us solve this 6d. This is 6d. So here you see we have this r is suppose x I cap, this is the position vector, y j cap, z k cap, right? So r will be equal to, this is vector r and its magnitude will be r is equal to root over x square plus y square plus z square. So Laplace of, we need to find, so that Laplace operator, that del square 1 by r is equal to 0. We need to prove that. So how to evaluate this? So del square is nothing but second order differential coefficient, right? This is the Laplacian operator. We need to find that, we need to operate by this Laplacian operator by on 1 by r. So 1 by r, if r is equal to this root over x square plus y square plus z square, then 1 by r will be x square plus y square plus z square to the power minus half, right? You can write like that way. And let us find first, let us differentiate this first with respect to x partially, then what you will get. So if you differentiate it partially, then with respect to x you must consider y and z as constant. So it's going to give you minus half x square plus y square plus z square whole to the power minus 3 by 2. Again, if you differentiate this term within the bracket because of function, so then you will get twice x, 2 cancels. So here you can see this is going to be equal to minus x square plus y square root over 3 by 2, and let me write the x here, okay, minus x into this. That's what you will get. Now if you differentiate it again in order to find this second order differential, the second order derivative, if you differentiate it again, then what you will gonna have, and this one, right? Okay, here you have to consider this minus x as u and this part as v. Okay, we are going to use the product rule. So let's use the product rule. That derivative of u into v, you know that u derivative of v plus v derivative of u. So here we have used u into v, that product rule. So and doing so, what we have got, minus x derivative of the derivative of this part, this one, derivative of this part is your minus 3 by 2 x square plus y square plus z square and whole to the power minus 5 by 2. Now again, function of function, so if you differentiate this part terms within the bracket, then you will get twice x, 2 cancels here, and minus, actually that should be plus because of this minus sign, we are getting minus. So minus x square plus y square plus z square whole to the power minus 5, sorry, whole to the power minus 3 by 2 into, and derivative of x is 1, right? So we have got this, so we can write this way. So this is the result we have got. Now if you further simplify it, then what you will get? If you simplify this, you can write this one this way. So now let us take LCM, then you will get x square plus y square plus z square whole to the power 5 by 2, right? So here thrice x square plus thrice x square minus x square plus y square plus z square, that's how that's what you will get. Hope you have understood these things, how we have got this one, because here we have taken LCM of these two, and here you see this is, if you divide this by this denominator, that x square plus y square plus z square 3 by 2, then you're gonna get this x square plus y square plus z square, that into 1. So this is the result. So hope you have understood these things. These are very simple things. So if you remove the brackets and if you evaluate, then what you will get, 2x square minus y square z square. So here you will get this one whole to the power 5 by 2. So that's what you will get. So this is the second order derivative of 1 by r, that means x square plus y square plus z square whole to the power minus 1 by 2 with respect to x. So similarly, let me copy these things and let me paste on the other slide. Similarly, you can find, so I will copy this equation and this result. So let me rewrite this. So what we have got, this is our second order derivative of 1 by r with respect to x. So similarly, you can find the second order derivative of 1 by r, that means 1 by r means x square plus y square plus z square, x square plus y square plus z square whole to the power minus 2, right? So here you see, in order to find that second order derivative with respect to y, just replace this x by y and this y by x, then what you gonna have? Then you will get this result, right? Then in order to find the same with respect to z, just replace this y by z and replace this z by x, then that's what you will get. Here you see, this is the result you're gonna have. So that's how we used to we have got this derivative of 1 by r, that means x square plus y square plus z square whole to the power minus 1 by 2 with respect to z. So if you add all these three results and put in this equation, in above equation number 1, suppose if you use these three results here, then you're gonna have this. So here we are going to take this one as LCM, that x square plus y square plus z square whole to the power 5 by 2. We have taken all these three denominators as LCM, and here in the numerator you will have this, right? So now y square minus y square cancels with plus 2y square, right? Similarly, minus x square cancel with 2x square. Similarly, minus z square cancels with 2z square, right? So that's why here we will get 0 divided by x square plus y square whole to the power 5 by 2, and that's gonna be equal to anything divided 0 divided by anything is always 0. So that is what Laplace operator on 1 by r, that's going to give 0. So here you see, this is how we can prove this. So hope you have understood. Now let's move on to the next question. Now let us solve question number 7. Express the Green's theorem in a plane in vector notation, right? So Green's theorem in a plane, so let phi and psi be two functions of x and y. So del phi by del y and del psi by del x be continuous functions over a region R, suppose bounded by the simple closed curve C in xy plane. Okay, they are in xy plane. Then the integral along the closed curve of this phi dx plus psi dy is equal to the surface integral over the region R, that del psi by del x minus del phi by del y dx dy. So let us consider that this vector f is phi I cap plus psi j cap, and r is x I cap plus y j cap, that is the position vector. So that dr is this dx I cap plus dy j cap. So let me write these things on the other slide, in the next slide. So let me rewrite those things. Okay, what we have considered, let me write all these things here. So now you see, this vector f dot dr, the dot product will be given by phi I cap plus psi j cap dot dx I cap plus dy j cap, and that is equal to nothing but phi dx plus psi dy, that is nothing but this part, you can see. So this part we have got, so this part can be replaced by f dot dr, right? You can see this result. So now curve of vector f, if you find a curl of vector f, then you will get this. So as there is no z component here, we have taken here, you see, we have taken this one as 0 k cap. We can consider f is equal to phi I cap psi j cap 0 k cap. We have assumed that way, so we have put here 0, right? So if you evaluate this, then you will get 0 del psi by del z I cap minus j, here you can see 0 into this one minus del phi by del z j cap, then plus del psi by del x. So del psi by del x minus del phi by del y, that is k cap, right? That's what we're gonna have. Now you see, you have got this result, right? Let me write this. Now you can see that curl of f and dot product of this and k cap, if you say dot k cap, so these two terms will be 0, that I dot k and j dot k is 0, so k dot k is 1, so that's why we're gonna get this result only, del psi by del x minus del phi by del y, right? So this is nothing but this part is here, you see. So this result is nothing but this part of this theorem. You can see this part. So you can replace this by curl f dot k factor, and here you see this k is in this direction. Now you see we are taking the region on this xy plane, right? Xy plane, and z axis is perpendicular to this xy plane, and the unit vector along the z axis is nothing but k cap, right? So that's what we know that. And here you see in vector form, the Green's theorem we can write that if you replace this, if you see the left hand side, if you replace this part, that del integration along the closed curve, that phi dx plus psi dy, if you replace this one by vector f dot dr, then if you replace the right hand side by this result, that curl of f dot k, right, then you will get this. So you're gonna get this. This is the vector form. This is, and dr, this capital dr means, here you see, so we are taking the region r, right? We are taking a region r, right? And this r varies as x and y varies, right? So we can say dr is equal to nothing but dx dy, right? So this is the vector form of Green's theorem in a plane. Now let us solve question number 7b. Remaining question will be solved in the next part. Okay, so now let us solve question number 7b. So here you see we need to find that integration dv dot dr along a straight line from this point to that point, then from this point to again that point, and that point from that point to this point again. So first let me write v here. What is v here? That thrice x square plus 6y I cap minus 14 yz j cap plus 20 x z square k cap, right? That's what we have got. Now dr, what do you mean by dr? Dr is nothing but your dx I cap plus dz dy j cap, right? dy j cap plus dz k cap. So this is your dr, right? So if you find that v dot dr, then what you're gonna have, if you find the dot product of this vector and this vector, then what you're gonna have, you're gonna have thrice x square plus 6y dx minus 14 yz dy, then plus 20xz square dz, right? That's what we are going to have. So now let me write this on the next slide. Okay, so this is our v dot dr, right? So now if you see the question, if you read the question, let's move back. So we need to find this integral along the straight line from this point 0 comma 0 comma 0 to 1 comma 0 comma 0. Let's find that one first. So along 0 comma 0 comma 0 to, so along the straight line, 0 comma 0 comma 0 to 1 comma 0 comma 0. Here you see the variation takes place only along x-axis, because x is increased from 0 to 1, right? X varies from 0 to 1, and so that's why there is no variation along y and z axis. Y is equal to 0 here, z is equal to also 0. That's why as no variation along y and z axis, so dy and dz both will be equal to 0. That's why we can write that v dot dr, putting these values here, you will get integration, you can write that integration from 0 to 1 along this straight line from this point to that point, v dot dr will be equal to integration 0 to 1. Here you see, if you put y is equal to 0 and dy is equal to 0, dz equal to 0, then what are you going to have? So you're going to have only this result, integration 0 to 1 thrice x squared dx. That's what you will get. So now if you integrate this from 0 to 1, so you can, if you integrate this, then what you will get? Integration of x squared x cubed by 3, right? So this is from 0 to 1. So if you put the upper limits and lower limit, before that 3 will be cancelled, then you will get 1 cube minus 0 cube, that's going to be equal to 1. So now you see, we have evaluated integration of vector v dot dr along the straight line from the point 0 comma 0 comma 0 to what we have 1 comma 0 comma 0, then to 1 comma 1 comma 0, then to 1 comma 1 comma 1, right? We have evaluated up to this point. So we have got, when we have evaluated from 0 comma 0 comma 0 to 1 comma 0 comma 0, we have got the value of this is equal to 1. And when we have evaluated the same from this point to that point, then we have got 0, and from this point to that point we have got 20 by 3. So therefore, so what will be the integral over this part, total part, right? So if you add all these three values, then you will get this 0 to 1 integration v dot dr, adding all the values, you will get this equal to, so you will get 23 by 3, right? 23 by 3. This is what this is nothing but value of integration v vector dot dr vector from along a straight line from this point to that point and that point to that point, that to that, right, is given by this one. So this is our answer. That's how we can solve. So here you see, in this video we have solved up to this is question number, I think, b 7b, right? So in the next video we are going to start from the next question. So hope you have understood, and if you like the video, hit the thumbs up button. And again, I'm saying, please share with your friends and help me to grow my channel and inspire me to create new contents for you. And if you're new, subscribe the channel. So hope you have enjoyed this. So see you in the next video. Thank you for watching, and stay connected, and next video will be uploaded soon, part 4. Okay, so thank you.